It's already hot in here and it's only 8 o'clock, so I'll try to make this a short intro. I started editing the video, which is like the second half video for the sander, and just it didn't have an intro. And so I've been waiting for a couple days to try to feel better. Recently had COVID again. This video spans about 2 years. For you guys, the timeline's still gonna work fine. It's gonna flow good as far as the video goes, but for me, there was a lot I design CAD in my regular day job, and so between that and farm life and everything else, this just was a low priority. So anyways, I felt like I needed to intro this video. So there's a couple of things that didn't turn out perfect. One would be, and I think it's in the footage, that I don't have a way to change the belt out without taking this off. That was a bummer. The other thing I wish I would have done, and I'm not even sure how I would have done it, because normally you melt inserts into plastic, but if I put inserts in this, they'd have to be put in place because of the hole registration, or I would have had to have scanned the holes so that I could have got good CAD data, which I didn't feel like doing. So the other thing I missed, which I won't show on camera, but basically dust comes out from underneath the table here. So when this is in the vertical position, I need to make a secondary cover that goes there, keep the dust from coming out there. And then I think the third item, now that I'm looking at it, would be that these two covers aren't even the same width. 1950s, they just didn't get them lined up. So this back plate here is bent. What does that look like? It's about a 1/4 inch proud. So just not going to deal with that right now. I want to get this thing usable. And then I may do a follow-up video, I don't know, but when I ran this the other day, the motor heated up. So either the start capacitor's toast, or they've got the start capacitor on the wrong windings, or something's not quite right. So I need to pull the motor again. I need to use the resistance of the windings and figure out which one, if I'm dripping sweat, I mean, I'm not kidding, it's probably 90 in here already at 8 a.m. I need to figure out which set of wires goes to the start windings, and then the other 4 wires should be run windings. I have it wired to run correctly in the right direction, but it heats up quick and I get an electrical smell. Now the other problem could be that one of the windings has got a short through the enamel, and the motor will be no good if that's the case. So just don't know. And then I also need to print a 3D top for this. That's a big deal. So, and then lastly, again, I may or may not do a little quib on this, but this table needs to be brazed because it's cast. I don't think I can weld it, so it needs to be brazed and then sanded down square on the edge. Somebody let the belt run, or there was either the table was loose or the belt ran. I can't even imagine how the belt would run against it, just because the belt, you can get it so tight. Who knows what happened, but sometime in its past, someone abused it and ate the table out in the corners. So, need to fix that. Other than that, I think it's going to be a fantastic machine. So with that being said, I hope you guys enjoy the rest of the video. All right, I realized I skipped some steps, so we'll kind of go over that. So this shaft, installing this shaft, there's a keeper nut here, but what you'll notice on mine, you can see the bearing slipping out. So this right here this housing is worn by a couple thousandths, and it allows this bearing to slip out. And what you have over here, you have a keeper and you have a bearing keeper. Now this was kind of trashed on mine. It's made out of aluminum. And so what you're going to want to do is recondition this. All the threads on this machine are very fine threads, extremely fine threads. And so you're going to want to clean your threads up with a wire wheel. These over here are also very fine thread. And so this shaft on mine can slip out this way. And what I'll do is pull it out and show you what the shaft looks like. It's a very simple setup. Okay, now it's going to be a pain in the butt. Come on out of there. And you can see that it's a shouldered shaft. It's got a shoulder there. And it just slips in. So that was the spacer that just fell out. And where did that go? Get all the grime off that real quick. And so this spacer goes on like this, and the thing that takes all this up are these wheels. And so this happens to be the inside wheel. I've got it greased and it's kind of old and worn. And then I just did a quick spray paint job on this. And the reason for that is I'm missing the casting out here and I'm missing the top casting, and so the wheel shows. For now, that's just gonna have to be the way it is. Oh, and the other thing is that I didn't show you guys is these bolts here hold this casting. It allows it to tip. And what you have a metal keeper here that's just a tapped washer, big giant tapped washer. And I painted mine, and it's just a big washer with 2 threaded holes. I'll probably replace those with Allen's, but like these. But for right now, that's going to be fine just to get it assembled. So we'll put you guys back on the tripod. That rotated around so you can see it. And then here's my janky spray paint job. And we'll get this on here. And this is left-hand threads. So these are opposite threads so that it doesn't unscrew when it's running. And I'll have to see what size that is. All right, so it's 1.25 inches now. I'm hopefully not in your guys' road. And of course I got a little dust out here on the end, but this is now ready to go. I'm going to sand that edge right there and make sure there's no burrs. When I took that off, it was extremely stuck. This whole thing had not been serviced in any way in 30 years or whatever. So those 2 cast halves really didn't want to come off. There was dirt and all kinds of stuff jammed down in the shaft. And so I took a big screwdriver and worked my way around it, turning, to try to start to spread it. And then it didn't come off until basically the threads were raised where the bolt goes on, so much so that both of them got marks on the inside taking them off. It was very difficult. And so it was easier on the inside one because I sanded the tops of the threads before I pulled that one off. But what I ended up getting was a little bit of raised edges, and I'll show you guys what I'm talking about. So you can see, hopefully you can see right in here, you can see that they exactly matched up before, and they don't now. And that's from prying and just trying to get those two halves apart. You can see there's just little blemishes in here. They're small, but the edges, am I getting banding? The edges are very thin. I would almost recommend two, as large as you can get, something to pry two of them at the same time. So you're putting even pressure on the drum as you're trying to get it off. So one of those things, I'm not super happy about it, but it is what it is. So this nut is 1.25 inch left-hand thread, by the way. All right, I am driving this pin out right here. And the reason for doing that is there's a mechanism inside of here that is part of the tracking. And so I drove the pin most of the way out. I want to make sure I don't lose any washers or anything. I can't go out there. This mechanism does some sort of tensioning. I'm just going to clean it. I'm going to grease this bore and then pound the pin back in. All right, all cleaned up, and it's going to go back in. Now, the orientation is with the fingers down and the bump up. So, and we're going to grease it. It'll probably take the paint off the pin no matter what, but it's worth the attempt here. Extra grease. All right, guys, so next part is going to be a component of the tracking, which goes in here. I just got done cleaning it up. It looks like this. It's got a square bolt and a spring inside here. And then it's got this spring, and it's made up like this. So we're going to go ahead and stick that in. I'm not quite sure how that works. I think that it goes maybe behind this component. I'm not sure. Yeah, it looks like it does. So we'll get that in, and I'm going to replace these screws here, these flathead screws, with probably Allen head. I just prefer Allen over flat. I know that that's what they used back in the day. Not super keen on them. And I'm pretty sure this goes through that and behind those ears, like so. And so for right now, I will go ahead and put those bolts in just so that it can be assembled. But I will be making a trip to the hardware store and swapping these out for a more modern fastener. I'm not super keen on flatheads. And of course, the people that do these, like me right now, don't tend to use the correct parallel drive flatheads, and so you can see that's all cammed out. And that's just typically what happens with these flatheads. They get cammed out, and they're a grub screw type flathead, and so they don't, they're not in typically very good shape, and they're also quite hard to find. And so what we can sort of see here, get you guys straight onto this. This mechanism takes up this component here and drives this back and forth. So I'm assuming that that's tension for the belt. That would be my guess, is that's belt tension. Alright guys, I needed to reproduce these pin stops. They basically keep the, in fact I'll show you. They are the stops that when this thing is swinging back and forth, these stops adjust 0 and 90. And so what happened is the pin broke off on one of them. The head sheared off. You can see it's a flat head. And so I went and got grade 8 bolts and cut the heads off. So I'm at this stage here with the head cut off. And what you'll have happen is you'll have it where the head's cut off. These are already done, and I thought about it afterwards. And it's just rough cut, you know, it's a bad finish. So what you do, any old grinder will work. You chuck this up in your favorite cordless drill. And this is going to get loud, but basically you turn this on and you rotate this against the stone. And then of course you can take the edge off, but I'll do it real lightly so you guys can see it. And it gives it a nice radial flat finish. And you can also do the same to take the corner off the edge and chamfer it. Works great, give you a real nice finish. Alright guys, what I'm doing now is my cutoff wheels are too thick, so I'm draw cutting a flathead screwdriver. So I'm draw cutting a slot. Alright, I don't know if this is going to work or not. I haven't had real good luck with this thing. And I'm just trying to taper this a little bit. Oh, that fits way better. Okay, we're going to call that one good. So that one's slotted and done. This one's slotted and not done. Oh yeah. That almost fits too well. It's a little loose. Not bad. So we're going to call that good. Alright, this part of the video was supposed to be me servicing the upper bearings on the upper roller and just be a Oh, my hair. Just be a real simple video on how to service the bearings. It's going to take the heat or the dust shields off and repack them with grease and just be done with it. And it turned into like probably the biggest ordeal of the job. So what happened is the upper wheel, the upper sanding, it's a sanding, the upper, so what happened is the upper sanding drum has bearings and it's supposed to have a floating axle. And I more or less beat on it with a pretty large hammer. It smashed my thumb. It almost broke my thumb. And I actually started to mushroom the end of the shaft out. And then I remembered that old thing about heat. And so I ended up heating the shaft up and got it out. But it wasn't without a really big deal. And so I'll kind of show you guys the aftermath here. So yeah, those would be bearing cages, busted inner races, all kinds of good stuff. And what it is, this housing, let me grab the shaft. This shaft would just normally slide out, no problem, right? It's a floating shaft. Take the keeper nuts off over here, and this just 2 jam nuts. Take those off, slide the shaft out. Well, because people don't maintain things, basically that shaft was combined with the dust from sanding and it turned it into almost like a glue. Like it was, I literally pounded so hard on it, I was afraid I was either going to bust the cast iron casting or I was going to crack these cast aluminum wheels. And I mean, I pounded on them so hard. Oh wow, that's crazy. So hard, let me find the right one, that those marks right there are from the wheel hitting the casting in here or over here. And so what ended up happening is the inner race on the bearing and these were froze to this shaft. And you can see some of the marks there. And the only way I got it off was by heating it up, and I pounded and pounded on this thing to get it off. Just to get it loose enough to get the bearings out, I had to take those inner races off. So when you take these keepers off, you can slide all these bearings over to one side of the race. So you can essentially move all the bearings over to one side, and then you can actually get the shaft to move over and then all the bearings drop out. And I mean, it was such an ordeal. And so if you have happened to come across one of these and the shaft is frozen due to neglect or no maintenance, before you go pounding on this thing like crazy, try heating it up. Now, I know heating it would have probably caught the rubber seals on fire. And so I probably would have had to have taken the bearings apart anyways. The grease would have started smoking. But so I took the bearings apart and I was left with just the races. I was able to use, if this doesn't tell you how hard, sorry guys, I had to pry, that right there would be the result of using 2 flathead screwdrivers to pry the inner race off of the bearing. And so I was prying so hard I actually broke one of our fairly large screwdrivers. I mean, it's not a small screwdriver. What an ordeal. It took me all day yesterday, smashed my thumb, thought I broke it. I hit it so hard with the hammer. So I don't know what lesson there is to be learned other than maintain your equipment, I guess. So got bearings coming. They won't be here till Wednesday, and I'm going to go ahead and clean this shaft up and polish it and do a bunch of cleaning. The bearings, the casting is loose enough that the bearings are not well retained in the cast iron casting. And that was my experience with the casting over there too. The big red one there on the bottom, those bearings tended to slip around as well. And so, you know, I don't know that there's a lesson other than I wish people would maintain equipment, but you know, that's what you get when you buy super duper old equipment that hasn't been maintained. I sort of expected it, maybe not as bad as this insane mess. Yeah, so I'm gonna clean up some of the pieces here. So for you guys, it's only been a couple seconds, you know, video magic. For me, it's been, oh, good 3 weeks, 2 weeks maybe. I can't even remember. I got COVID, and I got it light comparatively to, from what I hear, a lot of other people got COVID. I had chronic fatigue for about 5 or 6 days, and this has been a tough road. COVID is a really sucky deal. So I'm back to putting this belt sander together. This morning I was polishing journals, so this is just a piece of 600 grit wrapped around, you know, a piece of shaft I had in here, tubing. And then I used some like t-shirt to pad it out, wrap it in there until it fit the bore. And these cast wheels were all screwed up inside and just tons of junk in there. And they're still not wonderful, but they're as good as I can get with 600 grit. So clean the bores up. I'm gonna get this upper assembly painted, this casting. Gonna get this upper assembly together. So pretty simple stuff. Just got to put the shaft in there and get the bearings in and get stuff tightened up. Alright guys, this side of the bearing has grease, or I mean it has a shoulder. And this is the side that gets the keeper. There's a keeper that goes in there. And it fits pretty well. So we'll get something to tap that in. I gotta find something the right size. So in this case, it looks like a 1-inch socket. Fits the outside race pretty much exactly. And she's up tight. One more time, just to make sure. Okay, and then there's a keeper nut, or a keeper ring that goes in there. And it's made of aluminum. Now I had a heck of a time getting this off, so like I said, I think in a prior part of the video, this should slide in and out. And if it doesn't, it's probably gunked up in these wheels. I'm just going to gently tap this around until it comes up tight. Right now I'm still able to just thread it by hand. Okay, I think that's up tight. So I'm going to give it a couple little taps. Alright, that should be up tight. Now this other bearing goes in here. I think that's after it free floats. And that's after these shafts go on. I don't know which side. There's two spacers, and I don't remember which side they go on, so I'm gonna have to figure that out real quick. All right, I learned this technique from Diesel Creek, and that is this bearing is too loose, and so I'm gonna raise the journal a little bit. And that's going to retain the bearing because the bearing race is too loose. Get this one in there. And then it's this washer is a huge pain in the butt to get in, so be prepared for that. There we go. No. 3/4 inch is what these little nuts are. Dang. And I gotta have something to hold the other side. Alright, I'm guessing you gotta pre-tension these bolts. Now there's it's like a jam nut setup, so I gotta get another hand driver and dang it. It's 3/4 inch or 19 millimeter that fits it. But I gotta tension it by hand because I can't tell how tight I'm getting it. Okay. All right. So theoretically, if the stack up's correct, it shouldn't preload the bearing, which is why they made this bearing float, is so that it wouldn't preload the bearing. I think it's kind of a shit design, but whatever. Not up to me. So I'm gonna get it tighter. And then I'm going to put these jam nuts on. All right, so the top piece goes in these runners right here. I don't know the way it goes in. It needs to be adjusted somehow. So I'm guessing it goes up like this. So it goes like that, and then I don't know why it's not sitting up No, that can't be right. It has to go in like this. There we go. There we go. All right, so I'm gonna have to clean up this seam. This seam's pretty munged up from me prying on it. This was really jammed up. So that is here's the adjustment here, and here's the adjustment up and down the belt tightness. So got that in, got the holy smokes, it's already warm. Got the table next, and there's not a lot left to do. I got to get the pulley back on. And I got the belt, the thing that protects the belt, and just some small stuff to clean up. All right, 9/16. And gotta get the pointer on there yet and do some other stuff here. All right, so we gotta set zeros next, and I got to adjust the stop, among other things. So I got to grind this down a little bit. Okay, so I got to get this adjusted very carefully. And I probably need to change this. There's a whole bunch of stuff to adjust here. So part of what I need to adjust is this piece here. This is wrong, so I need to adjust that. So let's tighten that down. And what I need to do here is get a straight edge across the, I I need to get a straight edge from this wheel to that wheel, so shoot. Alright, so I took this plate off for just a second to try and get this lined up here. Now we're going to flip this thing back around. Whoops. Get this back on here. Oh boy, and then we're gonna see about getting this thing level here, or square. So I believe it needs to go. Boy, that's real close. That's exceedingly close. I think that's it right there, so I'm going to call that 0. And then I'm going to adjust the pointer here. I hate flathead screws so much. Okay, so that reads 0. Now, there's one more setting, and that is, I believe, .45, which I need to get the set screw. Alright guys, I'm just trying to get this thing set up at 45. I'm having to use 2 levels because the included angle is 135. So it's open down here, which means it needs to go a little further. So, oh my gosh. Alright, so with all that screwing around, the table's finally adjusted. The stop itself's on a roll pin, and you know, it's a 50-year-old machine or whatever, so the whole thing's sloppy. Some things I'm not happy about. I dented this upper roller. You can see it right there. I dented it. So, ow, sheesh. This is like, it's like retard filming. So the platen is flush, or I don't know what you'd call it. Flush is the word I'd use, but I'm trying to think of something else. With the wheels, with the drive wheels, and then the table is square to the platen. So basically the last thing I got to do is get the drive wheel on, and then I got this guard to paint for the belt. And I got this guard to put on the back to keep your fingers out of the belt. And then I gotta screw around with the motor. Whoever installed it was an idiot and they didn't know what they were doing, and so the motor needs to be installed and done properly. So we'll get there. Alright guys, so I've been working on a couple things lately. The weather's been really hot, 90s, 100s. We had 105 not too long ago. So it's been hard to get out here. If I don't get out here at like 6 in the morning, it's just smoking hot. I think it's 9 o'clock now, and it's like, it's getting up in the 85, 90 degree range already. So this motor, this is typical of old equipment. This motor wasn't taken care of. In fact, whatever electrician was in here, I'll show you guys what I'm dealing with real quick. So whatever electrician was in here, this is, I believe, an exciter wire, this red wire. I believe it activates the stator or whatever there's a component that has brushes on it that runs on a ring, and this wire activates that. Well, this wire was so loose that just jiggling those wires and getting things cleaned up a little bit, it pulled off. Well, then that required me to take the entire motor apart, which you can't because of the brush and the stator ring. Again, electricians, I'm going to get this wrong. I'm probably calling it the wrong thing, so ignore my idiocy. But basically there's little brushes that run on a ring, and you can't pull the motor out towards the you can't pull the motor out you can't go that way with it. It has to go that, no, I'm sorry. It has to go that way towards the pulley. It cannot go this way because the brushes sit like that. So irregardless, I had to take both of these housings off, pull the whole thing apart just to get this wire back on. And so you run into that with old equipment a lot. I was very frustrated that I had to take the entire motor apart. It doesn't have access like newer motors through the motor itself or the housing. And so, sorry guys, I'm already sweating. So I crimped the female spade connector down to where it was really hard to get on. That thing will not be coming off again. I'll show you guys some other stuff. So on this motor, it originally was just, in fact, what I'll do is I'll go ahead and slide this on. Let's see, they go like this. So we'll go here. And they're labeled just so I can kind of keep track of where they went. So the way that this was wired up originally, the white wire just went on the bundle I put through, and the black wire, quote unquote, since it's single phase, you can, I'm sure, move them around. Yeah, that's not gonna pass through very easily. So this was all just electrical tape together, and then it just was sitting like this. Just, I don't know what, I'm assuming maybe there used to be a box or something that went here. I don't know. It really sucks. It's not like a modern motor where it's got an access box. So what I did, I went and bought a large washer, and I'm gonna sand flats into it to fit this shape right here. But what it does, I'm gonna drill holes in it, and this will secure. It's the same shape as this little ring. You guys can't even see that, and it's being a pain in the ass this morning. However, this thing is actually going to screw down like this and secure it so these wires are semi-secure. And then I'm going to use, this is the wrong size, keep in mind this is the wrong size, but I'm going to use some split loom to get this all secured. This came with these two wires just wire nutted to the wires. So black, get this back out of the road. So the way it was wired up was like this and just wire nutted. I'm gonna butt connector these and get this all loomed up so that it's not such a friggin' mess. It's typical. Electricians, so I'm just gonna say it, and you guys, I know that that's what you got in your bag, and so I get it, I understand, but the back cover that covered the fan on this motor, one of the screws was, and I see this so much in the electrical industry, and I'm guessing that the ground screw is a 12, 24 or something that they have in their bag, but so the back housing for the motor definitely had been gotten into. The original nuts were these, they're all flatheads. So all this old equipment, you know, the sander off screen, the motor that goes with it, they're all flatheads and they always get rounded over. But these are more like a grub screw. And so they tend to maintain the flathead shape, and they've also got a sipe in the threads for when you put it in, it'll cut its own threads. Then somebody mismatched some kind of random flathead dome head screw that's rounded over pretty bad. And then I see this all the time. The electricians use these grounding screws, and I can tell it's a grounding screw because it's green. And it's got the like mini siping stamped into it from a factory machine. So normally when you put these grounding screws in, they'll self-tap their threads into the back of a box. And they're the right thread pitch for all kinds of stuff, because I find them in all kinds of electrical equipment. So somebody's been in this motor. I wish that it had all the original grub screws, but I'm replacing all of them anyways. It don't matter. So I ended up going to Ace Hardware and getting a modern head that's got a Phillips. I don't even like these. I would have preferred an Allen, but this is easier to access. These are those combo Phillips flathead heads. In hindsight, looking back the other day when I purchased these, I don't know why I didn't opt for a pure Phillips head. So that was a mistake on my part, but they're a far cry better than these flatheads. So we'll get those in and get the cover on. And then speaking of which, these screws, this plate holds, let's get you guys over here. This plate goes on like this, and it holds this back panel on. So the back panel goes like this. These reinforcement plates sit behind this panel like so, sit in here. And they hold this back panel on. Well, they're what I would call a grub screw. So let me see if I can get them real close to the camera. So you can see they got a tall head, and they typically will have a flat head slot that's deeper, and they don't tend to round out as bad. I just hate flatheads so much. So for whatever reason, the flatheads tend to get abused, and so I am swapping that hardware out with Allen heads, with AN washers, and the AN washers are a real narrow washer for the Allen head. So swapping those out for Allen heads, they're going to look nicer on the outside of the machine facing out. And that's where I'm at right now. I got the pointer on. I didn't remember to bring the pointer screw with me. I'll show you guys that. So the pointer screw is also flathead, and it's pretty bad. And so you can see the idea is to replace this screw right here. I did zero the machine out already. I got that pulley on. I got the bracket on down below, but it's not tightened down there. It needs to be tightened. And I'm not doing that until I get the motor back on. And so, man, it's hot in here. So, not gonna show you guys bolting stuff on because that's boring and retarded. I'm gonna get stuff bolted on, and then we'll maybe cover any other problems I have with that motor over there. We'll get the wiring all wired up, and then we've got this old school on-off switch, which I'm going to keep for now, and I think I'm going to paint. I don't like that it's all trashy, so it's this one here. The I think the hot side goes here, and then we've got a ground screw that goes, I think, back here. So we'll get that box painted so it looks nice like the rest of the machine, and I got to put a end on the cord and strain relief the cord because someone didn't strain relief the cord, and it's just ran through the bottom of the box and can chafe and cut and blah blah blah. So we'll get that fixed up, and we'll kind of do a wrap up when I get closer. So talk to you guys a bit. All right, guys, so done quite a bit of work to this thing. I'll just kind of go over what I did. So replaced a bunch of hardware, replaced that with an Allen head, replaced these with Allen heads, got this back plate on. I'm just about to get the cover to the belt on. I want to power it up. So there was a bunch of stuff that was hard to do down here. All right, so these bolts here were extremely hard to get in because the motor weighs a lot and it doesn't really line up with the bracket. But whoever drilled these holes back there, you guys probably can't see it, back in the back, they I don't know which one tensions the belt, so I had to fool around trying to get them in different holes. So that was a huge pain in the butt, took forever. On this side, what I did is I double split loomed this right here and then wrapped it with electrical tape until it fit this hole tight. So this is tight. There's you can't see it probably, but yeah, let's see here. You can see there's a little bit of slack, but it doesn't get into the belt. And then you can see that it's wrapped tightly and it fits that hole tightly. Holy cow, COVID has just kicked my butt. So next what's gonna happen is the belt cover is gonna go on, and that's pretty straightforward. Although it looks like I can't figure out how to put it on. I thought I had straightened that better than it is. I'm gonna have to fix that up a little bit. Anyways, belt cover goes on. So you can see the belt cover right here, and I got to get this box, like I said before earlier, painted. It's real close. I got a new end for it. Got to get a strain relief down here put on it, and it's ready to go. I thought about putting a light switch. I actually almost prefer a light switch, but I don't know. We'll see what I do. Alright, I got this bad boy wired up and plugged in over there. Let's see. Plugged in, wired up. There's no belt on it. I could put one on, but there's no reason to. They bolted, jeez, I'm out of view. They bolted these bands across the bottom, and I couldn't figure out. They serve no purpose. I think what was happening when this was new is it vibrates a lot. There's a lot of noise from this lower stand. It's original. I don't like the amount of noise it makes, so I may replace it, but for now it works. So I'm gonna hit the on button, it's gonna get real loud. So I'm pretty sure all that noise is from this lower tinny 1950s bass here. Just not sure what I'm gonna do about that, because the motor does mount in there. So for now I'm gonna live with it, but down the road I won't. So in the meantime, we'll get the chute made and get a belt on it and throw some sparks. I bought 36 grit, but man, it is just way too rough. It'll be great for like removing 1/4-inch plate, but that's about it. So I gotta get some 60 or 80 grit or 100 grit, something. Anyways, get back to you. Hey guys, I'm trying to wrap this belt sander up, and I did some CAD / cardboard CAD. I drew it up in CAD, took some measurements and drew it up, and made a first article, and then didn't like it. I'll show you that real quick. So this is the first one, and I'll show you how it goes on here. So you can, oh, almost dropped the camera. So you can see it goes on there like that, but it doesn't clear the frame by enough, and I want it to go up higher up here where the belt is going to be, and I don't want there to be a gap in the back here. So we're going to make some more cardboard CAD. Again, I drew this one up. I happen to be using SolidWorks, but you use AutoCAD, or there's a bunch of free versions, free options. So you can see all my old templates here. These are all the old ones. I just drew what was up and which way they went, and then taped them together. Got some boxes there to do that with. Here's my new templates. Same thing. Going to cut these out and then tape them up into a shape. Now what I want it to fit, I want it to fit the shop vac, which is 1 3/4 outlet, and I'm going to run it through a settling bucket so that the steel filings won't obviously catch the shop vac on fire. Part of what's going on is I'm not using that for wood, or if I am, it's very little. It's going to be almost exclusively metal. So I don't want metal shavings going down into the frame. If I didn't show that last time, I should have, but they had a port and a casting, and it's missing some parts that went down below into the frame itself and then came out the back, and I painted it and powder coated. I painted it, and I just don't want you know, metal shavings sticking to paint and melting stuff. So I'm going to do this exhaust chute here and be able to power it and actually pull the metal shavings off the belt. So we'll get started here. Alright guys, so I got the cardboard template done. I'm pretty happy with it. It's gapped a little bit, but I'm gonna actually take it in just a touch. So I'll show you guys how it turned out. So you can see the cardboard template from the front here. So this piece back here, if you watch earlier in the video, that moon-shaped piece is going to be thicker in steel, which is going to bring this edge out too far. I want these to line up. So I'll bring this back a little bit. But it fits good, clears down here. There's going to be a round tube that comes off there. And, wow, it's just like too washed out. Let's see. Yeah, so you can see the shape there, and you can see it fits pretty good. You can see it's a compound shape. It just barely clears right there. Anyways, so do a little bit of adjustment in the CAD file, reprint paper copies, and then I'll actually start cutting metal. All right. All right, for you guys, it's been a couple seconds. For me, it's been a couple months. So when I left off the last portion of this video, which was just a little bit ago for you guys, this was all done. It made a bunch of noise, all that good stuff, which is the base. And I was in a quandary, and the quandary was, or the problem I had with kind of wrapping this project up was dust collection. This thing is like kind of like a bandsaw for wood. Everything in the shop will be coated with dust, with grinding particles, metal grinding particles on, my GTIs in here now, and tabletops, and a mill, and there's a lathe back there that's going to be in a future video. And so my frustration is I knew that I would use this a lot, and it's on casters, but I also knew it would just make a mess in the shop. So what I ended up doing was, in the meantime between then and now, I got a 3D printer, and my goal was always to somehow, what my real goal would be to investment cast, but I don't have a foundry. I'm not set up to do any of that stuff. That will maybe happen someday. We'll see. So I wanted a solution for right now. And the solution for right now was a plastic dust collector. Now it sounds awful. You've got hot metal sparks coming off and going into this plastic dust collector that's going to melt. And it's a pretty simple solution. I'm going to line the inside of the dust collector with HVAC tape. So it's an aluminum tape. It's very sticky, and it seems to form to things really well. And there's no way that these sparks are going to melt through. I don't know why I keep using air quotes. The sparks are not going to melt through the aluminum tape. It's going to work great. It was hard to design because of, when Rockwell made this thing, they put the holes, let me get down here, guys, I'm sorry. They put the holes extremely close to the drum. So from a 3D printing standpoint, I have to tap holes, and the whole entire thing has, I don't know, an 1/8 inch clearance from the drum to the edge of the hole. It just was a bad design on Rockwell's part. They were dealing with cast aluminum, and so I guess back in the day, it was fairly easy for them to cast aluminum, apparently. And because this is also missing a top up here, and I may have covered that in other clips, I'm not sure. And it's even missing a sheet metal piece here. And I just got it and it wasn't complete. And so for now, the 3D printer allows me to print a top, which I haven't done yet, but it did print the bottom. And I designed it in SolidWorks, and it just gives me a way to get something now that fits well. It's going to fit the Harbor Freight shop vac, which is a whole nother story. I think I'm going to make a low pressure bin for it to go into, so there will be suction, but it gives a place for the steel shavings to drop out of the volume of air, but I want to use suction if I can, because it'll actually draw a lot of the lighter material into a low pressure area, and then it'll drop down into the bottom of the bin. So this is my printer station. I bought a Optiplex refurbished workstation off of Amazon. Just tried to go as low budget as possible. This screen is terrible. It's got a real blue hue, but I repurposed all this stuff. And what I started out with, my original intention was to do a sheet metal setup, but these are always hard to fold and weld and not have them just look like crap, puckered, and get out of there, spider. And also it was hard to get an outlet because you're going from square to round. And again, I could have, scab welded a round in here. And I started to go this route. This was my intention. And then I bought this from my cousin, and it's an Anycubic Chiron. And it's a large volume printer. It's old and slow, and he got rid of it because it's slow, but it's a good printer. He did a great job aligning it, and I haven't had any problems with it at all. And so I thought, well, I use CAD every day, so why not design something in CAD? And so I ended up coming up with this shape. So you can see they're kind of similar. Make sure you guys can see that. Yeah, similar. They both come out over here. They both have taper to clear the table over, or the base over there. I haven't tested this yet because I wanted to get it on video with you guys. These are, if you know anything about 3D printing, these are support trees. I'm using Cura, I believe. And I think this came out really well. It's fairly thick. You can see where the holes are. I put trees in. I wish I could have told it not to. I don't know the program very well. But anyways, so this is the shape. I'll get you guys in a little closer so you can see it. So obviously that's the shape of where the drum goes and the holes. And then I'll give you kind of a view from each direction. And this is the 3D printed shape that I printed. I got to break the trees out, get that all cleaned up in there. This happens to be the exact same diameter as the Harbor Freight shop vac. You guys tilt it up just a little bit now that I'm standing. And so what I plan on doing is getting a little rubber boot that goes here and adapts the two when I want to use it. But anyways, I'm going to get this cleaned up and go check fitment on the machine, and we'll get back to you. All right, guys, what I did is, obviously this thing's going to throw sparks off when it's being used. And so I wanted to, obviously it's plastic, I wanted to line it with something. I think I said it before. So I used HVAC tape, and you can actually see the silver HVAC tape, and it lines the whole inside. You can see it around the rim of the part. And I just used a closed-in socket and the backing material from the HVAC tape and rubbed all the wrinkles out. I made sure that I worked from the bottom to the top, so like shingles, it all runs downhill. There's no joints facing up that can get hot pieces of metal under them. So it should work fine. I'm gonna get it bolted up and see how it fits the machine. All right, so one thing I didn't anticipate is can't change the belt without taking it off.
That was a big mistake on my part. Not quite sure how I would have dealt with it, but would have designed something. So I get to take it off each time I want to put a belt on, which shouldn't be too often, but that was definitely an oversight on my part.